To keep warming below the critical 2-degree threshold, we need to cut 7 billion tons of greenhouse gas emissions every year. Doubling the average fuel efficiency of all cars from 25 kilometers per gallon to 50 would save 1 billion tons. But we would still need to cut billions more from our carbon footprint to stay on the safe side of +2 degrees.
We have an arsenal of solutions already. It's going to be solar, and it's going to be wind, and it's going to be tidal power, and it's going to be thermal power. All of these different things working together actually give us a pretty good ability to get away from the fossil fuel economy.
They look like some giant robot army marching across the landscape. Wind power and windmills date back thousands of years. With today's technology, one wind turbine can power about 300 homes. They're a 100% clean and renewable resource. But wind power is no panacea.
The fuel is free, but the maintenance is not free, and we're seeing a lot of problems with the units.
And of course, nature controls the on-off switch. On a global level, it would take more than 2 million wind turbines to replace coal power plants worldwide. The ultimate answer may be just over the horizon. But the problem continues to grow. With each passing year, we consume more energy. The future will test the best minds in science. These are still the early days of climate change. The longer we wait to do something about global warming, the harder it will be to solve, requiring more science, more money, and more global cooperation. An international team of physicists in England has already started attempting the mother of all technological solutions: nuclear fusion. They're building a fusion reactor modeled on the single best power plant in the solar system, the sun. Harnessing that same power could mean a virtually limitless and self-sustaining source of energy without producing any greenhouse gases.
This energy lights up the universe, powers most of the stars in the universe. So what we're trying to do here is to replicate the same process on Earth and use this amount of energy to produce electricity.
It won't be easy. With the volatile gases involved, engineers can't work directly on the reactor's core. They depend on a new generation of robot, some of the smartest and most skillful ever invented to work in such extreme conditions. The core of the reactor will be nearly 10 times hotter than the sun. A powerful magnetic field contains the superhot plasma and prevents it from melting through the reactor's walls. Even if it works, and there's no guarantee, the reactor won't produce commercial electricity for at least another 30 years. As ambitious as it may be, fusion may appear relatively down to earth. Imagine outer space filled with a cosmic fleet of mirrors. One current research project estimates that 1 million mirrors, each about 3 feet across, could block out enough of the sun's heat to lower the Earth's temperature.
It's no good sitting around hoping that someone's going to invent some fantastical new source of free energy, or a solar mirror which is going to reflect enough of the sun's rays to keep us tolerably cool. The reality is we have to deal with what we've got, and we have to do it within 10 years.
With or without us, the biosphere has always done an excellent job of cleaning up after itself. the planet has both the resources and the experience to deal with global warming. It's done it before. Global heating also spiked during the Cretaceous era, between 144 and 65 million years ago. It is the age of dinosaurs. The climate is changing radically, but slowly, over millions of years, giving many species a fighting chance to adapt over time. A period of extreme volcanic activity floods the atmosphere with 6 times the CO2, sending the average global temperature skyrocketing. It takes millions of years, but nature scrubs all that extra CO2 out of the atmosphere. It's absorbed through natural carbon sinks in the oceans and plants, and buried deep in the earth. Then, over millions of years more, it's fossilized. Billions of tons of carbon infused with the power of the sun were buried throughout the Earth's history. Those fossils sunk deep underground, producing enormous reserves of coal and crude oil. That's where the CO2 nightmare ended for the Cretaceous period, and ours began. It's the final irony of global warming. The very same carbon that was scrubbed out of the atmosphere so long ago is now being pumped back into the air every time we burn those fossil fuels. And it's warming the planet all over again.
Lo and behold, humans come along, we dig the stuff up, we find it's an incredibly valuable energy resource, and without thinking about it, we burn it and return this carbon back to the atmosphere in the space of less than a century.
In effect, we're reproducing the extreme conditions of the Cretaceous era, only this time at breakneck speeds. So quickly that most species won't have a chance to adapt and survive. The world's appetite for energy remains voracious. Our carbon footprint is staggering. As global warming escalates, it also accelerates. At some point, climate change could take on a life of its own, and global warming would become a runaway train. The only question is, now that we know about it, what are we going to do? Even the worst-case scenarios of 6 degrees won't mean the end of all life on Earth. But the planet after extreme global warming would be radically different from the life we know today. How bad could it get? At that point, the best minds on Earth agree on 2 things. They just don't know, and they hope we'll never find out.